Chapter 5 Introduction to Probability. Calculating probabilities. How likely is it? If each outcome of an experiment is equally likely, the probability of an event is a fraction of favorable outcomes. Probability of an event is equal to number of favorable outcomes divided by total number of possible equally likely outcomes. A probability of an event is a fraction of favorable outcomes. Probability is equal to favorable outcomes divided by total outcomes. The probability must be between 0 and 1. The probability of an event is 0 implies the event can never occur, and the probability of an event is 1 implies the event will always occur. Example. Suppose I flip two identical coins. What is the probability that I get two heads? Solution. There are four equally likely outcomes. Let's say the nickel falls heads. Now for this specific nickel, the dime that we're flipping with this nickel can turn out heads or tails. If nickel falls tails, then the dime that we're tossing with the nickel can turn out heads or tails. Right, so there are four outcomes: heads heads, heads tails, tails heads, and tails tails. Now the outcome that we're interested in is heads heads. There's one such outcomes out of four. Favorable outcomes divided by total outcomes is equal to 1 over 4. Suppose I have a 50-50 chance of getting through a certain traffic light without having to stop. I go through this light on my way to work and again on my way home. This problem is very similar to the previous problem with coins. The first time you encounter the light, if you have to stop, then on the way back you can either stop or go through it. If on the way to work you don't stop at this traffic light, then on the way back you either stop or don't stop. So again, there's four different outcomes: stop, 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 don't stop, stop, and don't stop, don't stop. What is the probability of having to stop at this light at least once on the work day? What is the probability of not having to stop at all? Having to stop at least once, how many times does that happen? How many favorable outcomes are there? Well, stopping at least once is stopping once or twice. So the first outcome, stop, stop, is stopping at least once. The second and third outcome is stopping exactly once. Therefore, there are three favorable outcomes out of four. What is the probability of not having to stop at all? Not having to stop, that's not stopping on the way and from work. There's one outcome out of four. The first three rows list the situations where you stop at least one time, two times in the first row. There are three favorable outcomes. There are four total outcomes. Favorable outcomes divided by total outcomes is 3 over 4. 2. One of possible outcomes, don't stop, corresponds to not having to stop at all. There's one favorable outcome divided by four total outcomes, equals to 1 over 4. Probability of event not occurring is equal to 1 minus probability of event occurring. Example. There are several sections of English offered. There are some English teachers I like and some that I don't. I enroll in a section of English without knowing the teacher. A friend of mine has calculated that the probability that I get a teacher I like is probability teacher I like is 7 divided by 17. What is the probability that I will get a teacher that I don't like? Solution. Probability teacher I don't like is equal to 1 minus probability teacher I like. 1 minus 7 divided by 17 equals to 10 over 17. Suppose we toss a pair of standard 6-sided dice. What is the probability that we get a 7? What is the probability that we get any sum but 7? In this picture we have displayed two different dice with possible outcomes. So here this is one die came up with 1, the second die came up with 1 as well. Here we have one die comes up with 4, the other die comes up with 4 as well. We're interested in getting a sum of 7. So this outcome here, 1 and 6, this one right here, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. There is 1, 2, 3, 4, 5, 6 favorable outcomes out of 36 possible outcomes. Probability of a 7 is 6 divided by 36, or 1 over 6, which is 17%. Probability of event not getting a 7 is 1 minus 1 over 6, or 83%. The disjunction is the event that either A or B occurs. The probability of this disjunction is probability of A or B equals to probability of A plus probability of B minus probability of A and B. Think about sets and Venn diagrams when you look at this formula. A or B is a disjunction of two events, A or B. Example. Suppose a librarian has a cart with 10 paperback algebra books, 15 paperback biology books, 21 hardbound algebra books, and 39 hardbound biology books. What is the probability that a book selected at random from this cart is an algebra book or a paperback book? How many algebra books are there? There are 10 paperback algebra books and 21 hardbound algebra books. That's 31 algebra books. How many paperback books are there? There are 10 paperback algebra books and 15 paperback biology books. There are 25 paperback books. How many paperback algebra books are there? There's 10 paperback algebra books. There are a total of 10 plus 15 plus 21 plus 39 books. Solution. Let A be an algebra book and B be a paperback book. The probabilities, probability of A, probability of B, probability of A and B are probability of algebra book, probability of paperback book, and probability of a paperback algebra book. There are 85 books total. If you add all these books, you get 85 books. There are 31 algebra books divided by 85 books. That's probability of an algebra book. There are 25 paperbacks. So probability of paperback is 25 divided by 85. And there are 10 paperback algebra books. So probability of algebra and paperback is 10 divided by 85. Plug in these values in the formula. Probability of A or B equals to probability of A plus probability of B minus probability of A and B, which is equal to 31 over 85 plus 25 divided by 85 minus 10 divided by 85, which is equal to 46 divided by 85, or 54%. Example. The surface area of Earth is approximately 197 million square miles. North America covers approximately 9.37 million square miles, and South America covers approximately 6.88 million square miles. A meteor falls from the sky and strikes Earth. What is the probability that it strikes North or South America? One thing you have to notice here is that there is not a conjunction of two events, North America and South America. There is not a part of a continent that is both North America and South America at the same time. So probability of A and B is going to be 0. Solution. The total area covered by North and South America is 9.37 plus 6.88 equals to 16.25 million square miles. Notice when I have to subtract here the size of the part of the Earth that's both North and South America. Fraction of the surface area of Earth is 16.25 divided by 197, and that's 8.2%. The empirical probability of an event is probability obtained by experimental evidence. Probability is equal to favorable outcomes divided by total number of outcomes in the experiment. Suppose the city posted workers at intersections, and over a 5-week period it counted 16,652 vehicles passing through the intersection, of which 1,432 ran a red light. Use these numbers to calculate an empirical probability that cars passing through the intersection will run a red light. The favorable outcomes here is the cars that run a red light. There were 1,432 cars out of 16,652 cars that ran a red light. And the empirical probability of cars running a red light at this specific intersection is 1,432 divided by 16,652, or 9%.